So, now let us come to the phenomenon of capillarity. What is capillarity? So, it is the phenomenon of rise or descent of liquid in capillaries of small bore, that is a tube of small bore, over the adjacent free surface. So, it is the phenomenon of rise or descent of liquid in capillaries of small bore over the adjacent free surface. So, here we have two conditions. There is a rise of liquid and there is a fall of liquid. So, we have a capillary, means a capillary is something like glass tube of very small bore. So, I have just magnified, these are in millimeters. So, I have just magnified it. So, you see this is suppose water. So, this water is there. So, this is the free surface, this is the free surface. So, everywhere the water surface is up to here, but when I dip a capillary inside, the water will rise to this level, h height. So, this is, you see, the rise of liquid in a capillary. So, this is rise. So, you see here this tangent, this meniscus makes with the solid is theta, this is theta. So, in this case, so when the rise of liquid in a capillary takes place, then the angle of contact is acute. For water and glass, the angle of contact is 0. There is another kind of liquid. Suppose this is another kind of liquid in a vessel. Suppose I dip a glass tube like this. Then what will happen? Then this is the adjacent free surface. So, free surface everywhere. But inside the capillary, the layer is this descent of liquid takes place. So, this is, you can say, descent of liquid. So, here when descent of liquid takes place in a capillary, then the contact angle is obtuse. So, you see this angle with this side is the contact angle, this theta, this is obtuse. Here mercury in glass, example mercury Hg in glass. Here H2O, water, H2O in glass. So, two different examples, two different type of liquids are there.